In problem 29, there are a number of ways that this can be handled. We can treat this as a quotient as it is. We could, if we treated it as a quotient, we would use the quotient rule. We could also multiply 3x minus 1 by x to the negative 1/2 power. And that would allow us to use the product rule. So we could do it as a quotient, we could do this as a product, and we could also just simply divide each term by square root of x and wind up using the power rule for this. So if we divided 3x by square root of x and then subtracting from that 1 over the square root of x, which would be minus x to the negative 1/2 power, then for the 3x over x to the 1/2, we treat 3x as x to the 2/2, and when we divide two numbers with the same base, we subtract our exponents, so that would be 3x to the 1/2 minus x to the negative 1/2. And you could have also multiplied out the x to the negative 1/2 times 3x minus 1, and you would have gotten the same results there. 3x to the 1/2 times minus x to the negative 1/2. And that's probably the ideal way, whether we do it by dividing or by multiplying by x to the negative 1/2. That seems to be the ideal way. And just to show that that works there, I will distribute the x to the negative 1/2 to the 3x. And so we'll get 3. When we multiply two numbers with the same base, we add exponents. And so x would be x to the first, or x to the 2/2. So we multiply, when we multiply two numbers with the same base, we add, and that would give us negative 1/2 plus 2/2, which would be x to the 1/2. And then distribute x to the negative 1/2 times negative 1. So we could have done it as a product, or we could have multiplied it out, which we're going to do, and use the power rule, or we could have done it as a quotient rule. Any one of these ways should all give us the same answer here. So we're going to divide now, we're going to find the derivative now, and f prime of x is going to be 1/2 times 3, then subtract 1 from 1/2 gives me negative 1/2. Then it's minus, and we're going to bring down the 1/2, and it'll become plus 1/2. Then subtract 1 from negative 1/2 will give me negative 3/2. Now, in this case, there's something that I do want to talk about here. What we're normally going to do going forward with derivatives is we want to find out where the derivative is 0, and we'll talk about why that is at another time. But when the derivative is 0, important things happen there. And what the derivative being 0 means is you have a horizontal tangent. Well, let me just state this real quick. When you have a horizontal tangent, that means you might have a maximum value or a minimum value, or just a temporary stationary point where there's neither a maximum or a minimum. So what we want to do here is this. It's ideal to factor here, and I have a 1/2, so I can definitely factor out a 1/2. But on top of that, I want to factor out the least common multiple of x that I have here. And if they're negative, I'm going to take the smallest or the largest negative number. So that would be x to the negative 3/2. Let's say I'm going to take out the most negative number, so x to the negative 3/2. Now I brought out the half already, so I'm still going to have a 3 in here for the first term, and I'll have an x. Well, what would the power be? I want to multiply two numbers with the same base, that would be x, and then I want to add their exponents. Negative 3/2 plus what gives me negative 1/2. Well, negative 3/2 plus 2/2 will bring me back to this term. So when I multiply two numbers with the same base, I add my exponents, so that would give me a net of x to the negative 1/2 as above. But x to the 2/2 is really just the x to the first power, so I don't need that exponent at all. And then I have plus 1. Now because x to the negative 3/2 is 1 over 2 times x to the 3/2, so it's third power square root, which can never be negative. And it can never be 0 either, since the numerator is 0. So it will be 0 when 3x plus 1 is 0, or x is negative 1/3. So this problem didn't call for that, but we will do that in the future a lot.